Hi, this is Dr. Bay, and here's Bugsy, and today we're going to go over the IUPAC rules of organic nomenclature. We'll delve into how to name acyclic molecules specifically, so stay tuned.
Organic chemistry,
taught by Dr. Bay.
reaction mechanisms,
Reactants to products.
retrosynthesis,
Target deconstructing.
molecules, spectroscopy, soaring through the sky, triumphantly fly, give rise to the complexity of life, living on a dream across the seven seas, learning about spectroscopy. Organic chemistry.
So in a previous video, we went over the different types of functional groups that you'll need to be aware of for this class, and I'm going to show it here again because we'll need this chart to understand how to name various molecules. Another resource that you should save is this chart on functional group priority, which goes from lowest priority at the bottom to highest priority at the top. And we'll get into more detail as to what the second and third columns mean later in this video. So for now, just save this chart for reference throughout this. So a system for naming molecules was developed by the International Union of Pure and Applied Chemistry, which stands for IUPAC, in 1892, and it's a systematic set of rules to name both acyclic and cyclic compounds, but for this video we will only focus on naming acyclic compounds. The first step of naming a molecule is to determine the primary functional group, or FG. Molecules with single bonded CC and CH bonds do not have functional groups, so alkanes will have the suffix or ending of ane, just like the molecule shown on the right. When there's more than one functional group in a molecule, the group with the highest priority is usually the more oxidized one. In this example, it contains both an alcohol group and a carboxylic acid group. So if we refer to the functional group priority chart, we'll see that carboxylic acids have higher priority than alcohol groups, so the carboxylic acid will be our primary functional group, giving the molecule of a suffix of oic acid, while the alcohol group will give us a prefix of hydroxy. If your molecule has alkenes or alkynes, they are often only written in the suffix. If there is a higher priority functional group present, the alkene or alkyne should be written after the root of the name, but before the suffix of the primary functional group. For this example, this molecule has both an alcohol group and an alkene. Since the alcohol group has higher priority than the alkene, the suffix will be enol. En for the alkene, ol for the alcohol. Step 2 is to determine the primary carbon chain, which is the longest carbon chain in the molecule that contains the primary functional group. Recall that each point or vertex in a bond line structure is a carbon atom. So in this example, the first molecule on the left, which includes the alcohol group, is the better primary carbon chain than the second or third molecules that exclude the alcohol group, even though they are technically longer. If there is more than one option, choose the chain with the maximum number of multiple bonds, like alkenes or alkynes. In this example, the first molecule on the left, which includes both alkenes, is better than either the second or third molecule that only includes one alkene. And if there are two chains of the same length, choose the one with the maximum number of substituents. In this example, the first molecule is better because it has two substituents rather than the second molecule that only has one substituent sticking out of the primary carbon chain. Step 3, name the primary carbon chain as well as the primary functional group. To do this, you're going to give the same name to the chain as if it was an alkane, but replacing the ending ane with the suffix attributed to the primary functional group. And a table of parent names for alkanes is shown on the right side in orange. In this example, the carboxylic acid is our primary functional group, and the rest of the molecule is an alkane. So it will have the root of pentanoic acid, where pent is for the 5 carbons in the chain, AN is for the alkane, and oic acid is because the carboxylic acid is the primary functional group. Step 4 is to number the primary carbon chain such that the primary functional group is on the lowest number possible. For example, the first molecule where the alcohol group is on C1 is better than the second molecule where the alcohol group is on C5. If the number for the functional group is the same in both directions, number the chain so the other substituents are on lower numbers. The first molecule, where the 2 methyl groups are on C2 and C4, is better than the second molecule, where the 2 methyl groups are on C3 and C5, which are larger numbers. And if the number for the substituents is the same in both directions, number the chain so the first substituent in alphabetical order has the smaller number. So the first molecule where bromine is on C2 is better than when it's on C5. Step 5 is to indicate the position of the primary functional group in between the root of the name and its suffix. For example, this molecule has 5 carbons, so we'll use the root pent. Since the alkene is the primary functional group, we'll use the suffix ene or ene. The double bond of the alkene starts on C2, so this molecule is named pent-2-ene. Another example is this one, where there are 6 carbons, which means we'll use the root of hex. The alkyne is the primary functional group, so we'll use the suffix yne or ine. The triple bond starts at the C2 position, so this molecule is named hex-2-ine. There are some exceptions to this rule, though. There is no need to indicate the position of the primary functional group when it can only be bound to C1, like carboxylic acids, esters, amides, aldehydes, and other terminal functional groups. And when only one position is possible, like in this example of butanone, there's no need to indicate its position. Step 6 is to name the substituents using the positioning established from step number 4. Alkyl groups are substituents that take on the ending YL. If you have more than one of the same substituent, you have to use what are called multiplicative prefixes, which have no effect on alphabetical order. In the top right example, the longest carbon chain has 5 carbons, so it has a root of pent. The whole molecule consists of single bonds, so we'll include AN in the root. And the alcohol is our primary functional group. So far, we've got pentanol as its name. But at C2, notice that there's a 2-carbon chain, which stands for ethyl. So the full name would be 2-ethyl pentanol. In this next example, the longest carbon chain includes 6 carbons, so it will have the root of hex. The alkene is our primary functional group, and it starts at the C3 position, so the name so far would be hex-3-ene. And then we have 2 methyl substituents at the C2 and C4 positions, so its full name would be 2,4-dimethyl hex-3-ene. And lastly, in step 7 is to assemble the entire name by writing out the numbers for the substituents listed in alphabetical order. Remember to separate the position of the substituents using commas and then use hyphens to join the name to the numbers. So in this example, the longest primary carbon chain is highlighted in purple with 6 carbons, giving us a root of hex. The alkene is our primary functional group starting at the C3 position, so far that gives us the name hex-3-ene. And the bromine group is at the C2 position, and there are also 2 methyl groups at the C3 and C5 positions. So based on alphabetical order, we're going to first list the bromine and then the methyl groups. Remember that the di in dimethyl does not count in the alphabetical ordering. It's only the core substituent name, which in this case would just be methyl. So the final name of this molecule would be 2-bromo-3,5-dimethyl hex 3-ene. So in summary, the IUPAC rules of organic nomenclature include Step 1, determining the primary functional group, Step 2, determining the primary carbon chain, Step 3, naming the primary carbon chain, Step 4, numbering the chain, Step 5, indicating the position of the primary functional group, Step 6, naming all substituents, and Step 7, assembling the entire name.
Organic.